So now let's take a look at what it means for a pointer to point to a struct. And given that the structure also conveys information about the size, how would a pointer work in that case, right? So let me set up the example first, and then let's go from there. So the idea is that we need some sort of a struct which has like elements within it. In this case, I have taken like long int, then followed by like a float, and then followed by an int, right? So I suppose these are the elements, and we'll see that in the code as well. But the idea is that we have this struct now, and I call it, I suppose, my struct, right? Let's kind of quickly confirm that. Yes, it's my struct. Actually, now that we are at it, let me just confirm. Yes. Okay, all of this is correct. So then now, how would my struct look in the memory? Like how much, if I were to do my struct uh, var uh, and then, go by the dot notation to assign some values, let's say 1, 1.0, and 1. So how much memory would it take, and how would it look like? So the way this happens here is, so var would be provided some memory. The variable would be pointing, or not pointing, but it would be assigned some memory, some bytes in the memory. And so the first four bytes would be for A, right? So if it's starting at, let's say, this memory address, uh, you know, this memory address, then the first 4 bytes from there would be where A is available, or mm, mm, essentially those 4 bytes are for A, followed by, or actually one correction, I was just looking at A to be an int. Since A is a long int, actually it wouldn't be, it wouldn't be 4 bytes, and this is kind of, oops, incorrect. Uh, so A would actually, take up 8 bytes in the memory, right? And hopefully these are 8, but these would be like 8 bytes. Just because, on this machine, long int is 8 bytes. And then followed by a float. So next four bytes would be for B. Right? And so these are like 4 bytes. And B would be a float, followed by C, which happens to be 4 bytes, right? So we have something which is 8 bytes, 4 bytes, and then 4 bytes. So in total, um, the struct would consume about 16 bytes, right? So 8 here, 4 here, 4 here. So 8 plus 4 and 4 is 16. So then the question is, when we have, let's say, a star PTR, which is pointing to address of var, meaning somewhere, there is PTR, which is now holding the address, uh, coffee, so to speak, and then that means that it is going to point here, right? And so now the question is, how do you go about, first off, addressing different elements within the pointer, or different elements within this memory region, and how would the syntax for that look? And also, because this PTR now, okay, I should have written, so this my struct, okay, struct my struct star PTR, right? So yeah, so struct my struct star PTR. This PTR now knows that, hey, it's pointing to a struct, and that struct is 16 bytes, right? So the following operations on this memory region, treated as a struct, um, the CPU would be able to infer how many bytes to go and kind of hug, right? or dereference, so to speak. And then also the question is, how do you dereference? How do you dereference a struct, right? A data type that is a structure. So, okay, let's discuss on that. So let's talk about, struct, my struct, star ptr, and that is pointing to var, right? So how do we go about dereferencing elements A, B, and C? Now, in the earlier case, when we had int star p equals to address of I, where there was int I equals to, let's say, 10, a star p equals to 11 would mean that we are wanting to go to the address saved by p, take the contents or address the contents in that region, and we would address 4 bytes. Right? We would dereference that memory location and put 11 inside of it. That was how we used to do it earlier. But in case of a struct, what now happens is when we dereference the PTR, it says, hey, okay, I understand this is like dereferencing a struct, but then you have to tell me the element within that struct that you want to, so to speak, address or dereference. And the other thing is that we put parenthesis around the dereference here, put a dot here, and then address the element that we want to address. So for example, if we wanted to target this address here and dereference 4 bytes for C, the way to do that would be ptr brackets and then followed by C, and whatever, 10, for example. And then the question is that these parenthesis here is just to help the compiler understand, hey, read the content here as dereferencing a struct, and then we want to step inside the struct, right? So for example, if we were to do var dot c equals to 10, that I say is same as doing this. And we'll take a look at all of this in code and as an example also, but this is what it means. Now, one thing that I want you to, again, brain tattoo is this is cumbersome. This is very, cumbersome, and this is too much code or too much of, brackets and parentheses, those kind of things. So there is a syntax or shorthand for this, which is very widely used, and that's what you will see all over the place. So it is, we say ptr arrow c, and that's the way that both of these are like equivalent. Instead of writing this syntax here, we just write like a arrow, right? And we'll take a look at this also. So let me clear this and let's go back to the code here. Actually, yeah. So what you see here then is the struct, which is my struct with long int a, float b, and c. So it consumes kind of total 16 bytes in the memory. And you can go ahead and kind of print the size of struct, um, like we did in the previous video. But okay, so this is A, B, and C. And what I'm doing here is creating a variable var, which has these elements and the value as like so, right? And this is, my claim is that this is var, right? So this is then var dot A, this is var dot B, and this is var dot C, right? This is how it is. At this point, if you see, I'm declaring ptr as a pointer to var, right? So somewhere again in the memory, there is ptr that is kind of, pointing to var, right? And then here is that special syntax, which is parentheses star ptr as dereference the ptr, but you can't dereference a struct like all at once. You need to address or refer to an element within it. And so the way we address an element or refer to an um, uh, refer to an element is by the dot notation here, right? And then what we are essentially doing is incrementing by 1 a and b and incrementing by 2 c. I chose to increment by 2 because -1 then converts to 1. That's the idea, easy to identify. Here I go ahead and print in the original variable form, which is var.a, var.b, var.c, and then also use the parenthesis and dereferencing notation for structs, which I just kind of alluded to a while back. Let me clear this and then we kind of scroll down here. So um, then what I'm doing here is demonstrating us replacing this syntax with um, with kind of this syntax, right? There could be a pointer here and an element here, and there could be a pointer variable here and the element of the struct here. That's what you see here. And then I'm again incrementing and then printing it in all three forms, right? Forms meaning the syntax. All right, let me clear this. And let's again, keep this much insight. Let's go ahead and do gcc main.c. Everything compiles, a dot out, and as you can see here, the original values are incremented, right? Uh, this is incremented to 125, this is incremented to 3.5, and this is incremented to 1 because of this math. And then these prints are same as these prints. And then we go ahead, use the arrow notation on pointers to struct and print these. And as you can see, much the same thing, except I have incremented it again by 1 and then by 2. So two points to take here. One is that the pointer to a struct, the dereference on that works in the form of dereferencing the element. There are parentheses involved. And the second important point that I want you to always remember is that the star ptr dot element okay, ptr dot element is same as ptr arrow notation a, right, element. So same thing. And this is super critical because you'll again see this being scattered around in the Linux source or even in the FreeRTOS source or any source code written in C. This is so common.